Welcome to This Explainer. Today, we're moving way beyond that simple little chat box and getting into the real nuts and bolts of making large language models do exactly what we need them to do. Have you ever typed out what felt like the absolute perfect prompt, only to get, well, complete garbage back? Yeah, it's super frustrating. It wastes so much time, and in a business setting, it's a total non-starter. So our goal today is to take you from a casual AI chatter and transform you into a deliberate AI engineer. We're going to give you the exact production-proven blueprints that top developers use to get absolute control over their AI outputs. To do that, we've got a great roadmap for you today. We'll start with the AI prompting problem, then build a foundation with the CRAFT formula. After that, we'll look at production-proven patterns, dive into eliciting reasoning with chain of thought, explore deliberate search with tree of thoughts, and wrap up with the future of prompting. Let's get right into it. Section 1, the AI prompting problem. We've literally all been there, writing that first, magical prompt that works perfectly on our own screen, only to watch it completely fall apart when real-world users get their hands on it. So, you gotta ask yourself, why do these seemingly perfect prompts fail in production? Well, think about it. When you're just experimenting locally, your environment is super controlled, right? The use case is narrow, and you know exactly what you want. But out in the real world, in an actual app, user inputs are gonna vary wildly in length and quality. And this is absolutely crucial. You have downstream systems to worry about. Like, let's say your application is expecting a nice, neat, structured JSON file to update a database. If the AI suddenly decides to write a conversational, friendly paragraph instead, boom, your entire application breaks. Just think about the naive approach of tossing the AI a really simple instruction, something like, write an email for a job. Honestly, doing that is kind of like throwing a paper airplane into a hurricane. Out in the wild, users make typos, they give half-baked instructions, they ask totally weird edge case questions. And the result on the other side? It's just chaotic, unpredictable output that completely misses the mark. So success in production isn't about writing that one clever magic prompt. It's really about building reliable defensive patterns that shield your application from all that inevitable chaos.
And to survive that chaos, we need a strong defense. That brings us to Section 2, the Craft Formula Foundation.
The CRA formula is really the absolute baseline for all solid prompts. You have to remember, at the end of the day, large language models are essentially just probability machines. They're just predicting the next most likely word based on their massive training data. If you give them a vague request, they're going to wander down the wrong probabilistic path. CRF is a structural framework. Think of it kind of like a pilot's pre-flight checklist. It ensures that those critical instructions are never, ever left out, which literally forces the model onto the exact path you need it to take. Let's quickly walk through these 5 building blocks. So C is for context, which gives the AI the background it needs to actually understand the situation. R is for role. You assigned a specific persona so it knows exactly how to act. A is for action, meaning the specific task you want it to complete. F stands for format, telling the AI if you need, say, a data table, bullet points, or just plain text. And finally, T is for tweaks. This is where you set your constraints, like telling the AI to use a maximum of 3 sentences, or maybe adjusting the tone to be super formal. And look at how powerfully all this comes together in practice. Instead of just throwing that paper airplane and asking for an email, you are actually anchoring the AI. By defining the professional career coach role, you instantly lock in the specialized vocabulary the AI is going to use. Providing the context of a first-round data analyst interview grounds the whole thing in reality. And then demanding a polite, concise format keeps it from just rambling on. It completely cures that bad prompt disease, mostly because you're leaving absolutely nothing to chance. Okay, but what happens when documents get super long and we need to lock down this behavior programmatically at scale? That's Section 3, Production-Proven Prompt Patterns. So a really massive issue with large language models is this thing called recency bias, or sometimes attention degradation. Basically, if you paste a huge document into a prompt, the model tends to just forget the instructions you gave it at the very top. To fight this, we use a defensive pattern called the instruction sandwich. Here's how it works. You place your strict system instructions at the top, then you insert the dynamic, unpredictable user input right in the middle, and then, and this is the crucial part, you remind the model of the exact formatting instructions at the very end. This reinforces the rules so the model doesn't just drift away when it's processing huge walls of text. Now, pairing that sandwich pattern with role-based prompting, that is how you scale your app. Try to think of a role as kind of a master dial for complexity and tone. By explicitly defining a persona, like literally telling the AI you are a senior backend engineer, you programmatically constrain the style and the technical depth of the response. The AI will just naturally use different, way more advanced vocabulary and debugging steps than if you had told it to act like a friendly customer support rep. It manages all that complexity without you having to micromanage every single word. All right, we are crossing the threshold now from standard formatting into actual cognitive emulation. Section 4, eliciting reasoning with chain of thought. Asking an AI model to just guess and answer directly is honestly a lot like watching a blindfolded guy throw darts. Remember, these models can't actually do math, they just predict tokens. But when you use chain of thought, or COT, you essentially force the model to build stepping stones. Instead of blindly guessing the answer to a math problem about Roger's tennis balls, the model writes out the intermediate natural language steps. Roger started with 5 balls, 2 cans of 3 is 6, so 5 plus 6 equals 11. By forcing it to actually show its work, it can basically see its own logic and predict the final number way more accurately. The really cool thing here is that when you ask a model to explain its reasoning step by step, you are literally allocating more computation to the problem. You're giving the AI a larger compute budget, meaning more tokens, and therefore more time to process the logic before it reaches a conclusion. This unlocks these complex math and reasoning skills that standard jump straight to the answer prompting completely fails at. Plus, as developers, this gives us this incredible, interpretable window to debug exactly where the AI's logic might have gone off the rails along the way. Now, let's start treating the AI less like a simple chatbot and a bit more like a classical search algorithm. Section 5. Deliberate search, or tree of thoughts. The tree of thoughts methodology takes reasoning to just an entirely new level by allowing the AI to branch out. It basically breaks a problem down, generates multiple potential thoughts, and then evaluates its own progress. And to navigate these thoughts, it uses classical algorithms like breadth-first search. In plain English, this means the AI explores all possible next steps across the board before diving too deep down any single path. And if it hits a dead end, it can literally backtrack and try a completely different route. It really mimics true human problem solving, kind of like a grandmaster analyzing a chessboard. And the results of this deliberate search are absolutely staggering. To test this out, researchers used the game of 24, which is this mathematical puzzle where you have to use 4 giving numbers and basic math operations to reach exactly the number 24. It's notoriously tricky because it requires looking ahead and sometimes backtracking. Using standard prompting methods, the AI had a measly 4% success rate. But with Tree of Thoughts, it achieved a massive 74% success rate. That is not just an incremental update, guys. It is a revolutionary leap in capability, all simply by changing how the model traverses its own reasoning space. As we've seen from all this, the era of relying on a single magic prompt is totally over. Section 6, the future of prompting. I want to leave you with a bit of a provocative thought today. As prompting evolves from basic text entry into actual software architecture, how are you going to rethink your entire approach to building with large language models? We are way past just typing out text requests in a chat window and crossing our fingers. Today, we're designing structured pipelines, implementing deep reasoning frameworks, and orchestrating complex cognitive workflows. Thank you so much for joining me to explore this explainer. Now get out there and take absolute control of your AI.